So in this sixth screencast, we will consider the elemental composition of the Earth's crust, mineral resources, and extracting mineral resources through mining. So this is a pie chart showing the elements that make up the Earth's crust and their relative percentage. And you can see that nearly 50% of the Earth's crust contains oxygen, another almost 30% silicon, and all of the other elements are available in much smaller quantities. Some are in relatively abundant form, like aluminum and iron, but once you get past aluminum, iron, magnesium, and calcium, all of the other elements are in very small proportions. So that has consequences in terms of their use and extraction. So next we're going to look at what our mineral resources are. All of our mineral resources are non-renewable. Non-renewable means that we can't just, doesn't mean we can't recycle them. It just means that we can't get more of them once we use them. We can recycle, that's different, but these are all non-renewable. So fossil fuels, which includes coal and oil, are non-renewable. They were formed from organisms that were found on Earth millions of years ago. Metals, such as gold, aluminum, and titanium, and non-metals, such as sand and limestone. So I'd like you to take a moment to consider on your own, what do we use each of these materials? What's the use by humans for each of these materials? Once you have considered what these materials are used for, let's go on with the screencast. So fossil fuels are obviously used for energy. Gold can be used as a currency or as jewelry. Any of the metals, including aluminum, can be used to conduct electricity, so those are very important to our modern life. Some materials, such as titanium, can be used for things like a hip implant, that people don't typically have an allergy to titanium, so it can be used to replace a hip, for example. Non-metals such as sand and limestone can be used to make buildings, glass, and other essential uses. And all of these mineral resources may be found in one of two places. Sometimes they're found on the surface, and sometimes they're found deep underground. Sometimes they're found in large quantities, concentrated quantities, and sometimes they're scattered and just mixed in with other types of rock. So when we obtain these resources from the ground, which is extracting them, when we process them, which is to put them into a form that we can use, and when we use these mineral resources, we affect the environment and human health in consequential ways. Also consider the fact that the mineral resources are unequally distributed, and that has social consequences. Oh, and here I have some of the examples of uses: energy, building materials, money, semiconductors, packaging, and medical implants. So there are 5 types of mining. 4 of them take place at the surface of the earth. That's strip mining, open pit mining, mountaintop removal, and placer mining. The 5th type of mining is called subsurface mining, and we'll consider that on the next page. So first of all, strip mining. Strip mining occurs when strips of soil and rock are removed to expose ore. When we do that, it produces waste, which is called tailings. I'm going to pause here, move ahead for 2 slides, and show you what strip mining looks like. So coal is a substance which is typically mined through strip mining. So you here have the topsoil with the trees in it, and those trees have to be removed. Deforestation has to occur. Then this area of subsoil, called a high wall, is removed so that the seam can be directly obtained with equipment or digging. And that coal exists in a seam running straight across. Then there's another layer of earth, an overburden, which would be removed, and yet another coal seam. And then there would be another overburden and another coal seam, etc., as you go down the mountain. So that's why it's called strip mining. The resource exists in a strip, and we remove one layer at a time. So a second type of mining on the surface is called open pit mining, and it's exactly what it sounds like. A large hole or pit is dug into the ground. That's when the resource is typically very close to the surface, and you see the open pit right from the surface. And copper is something that's typically mined this way. There's a big open pit copper mine not far from Salt Lake City, Utah, that is 3 miles across, and you can see it from space. Okay, a third type of mining is mountaintop removal. And that's what actually happens. The top of the mountain is removed. They put holes into the top of the mountain, stick explosives in there, dynamite, and blow off the top of the mountain to remove the overburden so they can get directly at the coal. This type of mining is very dangerous for, well, not very dangerous. It's less dangerous for the miners, but more dangerous for the environment. As you can imagine, all of that habitat is removed, which also occurs with strip mining and open mining. But then the amount of material that is left over, waste material, is significant. And since it's a mountain, usually that overburden of material, that waste material, ends up in the valley and often blocks streams and rivers. And the fourth type of mining, surface mining here, is placer mining. And that's when people search for metals and stones in river sediments. And they actually take a sieve and go through and pull out the material such as gold. And that's what used to happen in the gold mining days, the gold rush days, but it doesn't typically happen anymore. Okay, so here we're going to compare surface mining and subsurface mining. But let's first talk about subsurface mining. Typically what happens is a horizontal shaft is dug into a mountainside, and then a vertical shaft is built down into the mountainside to get to each layer of typically coal. So this is a challenge for the miners who often go very deep in underground. And when they go underground, they could be exposed to fires, gases, and many other materials that puts their health at risk. You may have heard of a canary being brought down into a mine, and if the canary stops singing, then they need to get out of that mine. That's because the canary is more susceptible to the gas and would indicate that there's a problem with not enough oxygen being in that mine or harmful gas being present in that mine. In addition, there are very serious respiratory diseases that result. Black lung disease is one of those. And the lungs literally get black as they breathe in the coal, and that damages, it's a substance, a chemical, and it's a particulate, and it damages the lung tissue and makes it hard to breathe. Usually in the past, that person did not succumb to black lung disease until they were a little bit older and had been mining for decades, so maybe in their 60s. Nowadays, though, miners are getting a type of black lung disease much earlier. They typically 30s and 40s. And that's because as the amount of coal becomes less available, it's mixed with other type of rock, a mineral rather, called silica. And silica is very sharp and also smaller, so it gets deeper into the lungs and causes more scarring. And so it's having a more significant impact in recent decades. Okay, so I have a couple of videos attached, actually a video and an article attached to talk more about subsurface mining. But now let's turn our attention to the table, which compares surface mining to subsurface mining. Surface mining produces significant dust from the earth-moving equipment, Whereas subsurface mining doesn't have much dust at the surface, but they tend to use more fossil fuels to power the equipment, and so that can still be a significant effect on the environment. Effects on water. Contamination of water that percolates through the tailings can be quite significant, and it can be even more significant with acid mine drainage and contamination of water as it percolates through the tailings. So I've attached a video also of the gold mine spill that occurred in 2015, and that will give you a sense of the serious effect it can have on water. Soil. So surface mining, the soil is generally removed from the site. If it was replaced, if the mountain was remediated, then it would put soil back. But again, much of the soil would be contaminated. Much of the soil is never put back because a mining company declares bankruptcy. And it's just not that easy to put a mountain back together. And it takes a long time for the soil to become more mature and for organisms to return to and make it a habitat. Okay, looking here at effects on biodiversity. Surface mining obviously alters habitat and destroys the areas that are mined. In subsurface mining, there's less damage to the habitat on the surface, but there is a lot of road construction, and that can fragment habitats. And last, the effect on humans. The surface mining has less effect on human health, but air quality and water quality can be adversely affected. Subsurface mining has very serious effects on human health. So since mined minerals resources are limited in supply and damage to the environment may occur when they are extracted, and we have to consider the disposal issues, we need to figure out what to do. So this slide here will show you some of the impacts, summarize some of the impacts, and also look at some of the ways we might be able to limit the effects. So first we have destruction of habitat, including mountaintop removal, which is significant. Then we have waste rock, where waste rock blocks valleys, streams, and rivers. So these two can be addressed if we do some reclamation work to restore a habitat. Dust is a significant issue, so dust can be limited by certain technological procedures to limit the amount of dust. Toxic chemicals are present in waste rock, and then they become more concentrated as you take out the rock that you want. So lead, mercury, and cyanide, all of which are damaging to humans, but also to wildlife, can be treated, or sometimes the chemical treatment can actually lead to making it more toxic. Land collapse can be a problem with subsurface mining, and there's even a mine in Pennsylvania that has been burning for many years and is expected to continue to burn until I think it's 2060, and so that's also an issue. Acid mine drainage can be an issue because as water percolates through the mine, it picks up the acids and concentrates them, and then that can cause damage to various streams or even aquifers that this acid mine water may leak out to. Black lung disease, asbestosis, accidental burial, explosions, and fire are also significant issues. Black lung disease and asbestosis can be addressed with regulations that require improved face masks or respirators actually to help prevent the miner from getting ill. Oftentimes though, the miner's mask, the respirator, gets blocked up with the coal, and they even remove their mask way before they should have because it's hard to breathe through these respirators, especially when they become blocked. So improvements in the technology there would be valuable. So accidental burial, explosions, and fire you might think don't happen anymore, but they do. From 1900 to 2006, just in the United States,